Hi, this video is for Chem 2045. We're doing problems for exam 3, and this is from the fall 2009 exam. We're going to do practice problem number 14. 14 says, which of the following substances will have hydrogen bonds between molecules? And they give us 5 choices to look at. So what we'll need to do is draw our molecules and see whether we have hydrogen bonding. And something to keep in mind is 3 special atoms, which are nitrogen, oxygen, and fluorine. These are important to remember because they are effective in hydrogen bonding between molecules. So if we look at our first one here, we have carbon in the middle, bonded to 3 hydrogens, and then a nitrogen, which has 2 pairs of unpaired electrons. So we have N here, nitrogen, on our molecule, but it needs to be directly bonded to hydrogen. This is because as an electronegative atom, if it's bonded to hydrogen, it's going to pull the electrons away from hydrogen, making it partially positive. But here we have nitrogen bonded to carbon and hydrogen bonded to carbon as well. So we won't have that effect in this molecule. So this substance won't have hydrogen bonding. Now this one right here, we have oxygen bonded on each side by carbon, which has 3 attachments of hydrogen on each. And then when we complete the Lewis dot structure, we'll find that we have these two pairs of unpaired electrons sitting on oxygen, and we think, oh, there could be hydrogen bonding here. But this one as well is not directly bonded to hydrogen, which means it won't have the same effect. So there will be no hydrogen bonding for this molecule. Now when we look at this one right here, we have carbon bonded to oxygen, which is bonded to hydrogen. And we have 3 hydrogens on this first carbon, and 2 hydrogens on the second. And completing the Lewis dot structure, we find that oxygen still has 2 pairs of unpaired electrons as well as it did over here. So now we observe that hydrogen is directly bonded to this strongly electronegative atom. So you're going to have a partially positive hydrogen atom here. And if we throw in another molecule of this substance, we'll have oxygen with its lone pairs of electrons bonded to hydrogen, and then drawing this molecule again. We see that these electrons right here are available for hydrogen bonding. We have a partially positive hydrogen. It's going to be attracted to these lone pairs of electrons. So this is called hydrogen bonding here. Now these hydrogens over here aren't going to be affected because carbon isn't highly electronegative like nitrogen, oxygen, and fluorine. So let's look at the fourth one, even though number 3 does have hydrogen bonding. So over here we have carbon bonded to 3 hydrogens, and that one's bonded to another carbon with 2 hydrogens. And this is attached to fluorine. Now when we complete the Lewis dot structure of this one, we find that fluorine has 3 pairs of unpaired electrons. This would be very effective in hydrogen bonding, but the problem is we don't have hydrogen directly bonded to fluorine. So there will be no hydrogen bonding in this substance. Now this last one here is hydrogen bonded to iodine. And if we complete the Lewis dot structure here, we find that we also have 3 pairs of unpaired electrons, which would be great for making a hydrogen that's partially positive. But iodine itself is too large for this to happen. So there will be no hydrogen bonding in this molecule either. Now this is probably an important one to remember, that size matters. So this one is too large for the hydrogen bonding to occur. So we should probably keep that in mind. So we have nitrogen, oxygen, and fluorine as our main atoms for electronegativity, and they need to be directly bonded to hydrogen. This is our answer.